Hello and welcome to Net 201. This is AWS Outposts Networking Foundations. I'm James Devine. I'm a Senior Outpost Solutions Architect, and I'm also a network SME. To start out with, we'll be talking about a quick overview of Outposts. We'll then dive into Amazon VPC and how that works on an outpost. We'll then get into local network connectivity, the connectivity to your on-premise location. Then we'll dive into regional connectivity, the connectivity we use to connect back into the region. And then we'll wrap it up with a quick demo to put some of it into action and be able to see this work firsthand. This is a 200 level session, so I'll cover some of the basics and then dive in a little deeper as well. So going through what Outpost is, it's really bringing the AWS experience to on-premises. It's designed to use the same hardware infrastructure that we use in our commercial AWS regions. So very similar hardware and configurations that we'd have in our region, and you're able to leverage that same hardware and our ability to deliver. We also, it's fully managed, monitored, and operated by AWS as if it was a part of our region. So a lot of the on-premise management and the way you traditionally work with hardware, you don't need to worry about. It's more akin to using the AWS management console where you don't need to manage individual physical servers or worry about underlying things like storage arrays and that type of on-premise components. It also provides a single pane of glass, being the AWS management console. So the same console, the same CLIs, the same SDK, everything that you come to know and love in the region and how you operate in the region extends with Outposts. So we have that same management plane with Outposts to provide that seamless experience to be able to have workloads run where they're best suited to run, be it in the cloud or on-premise with Outposts. Diving into the physical infrastructure, an outpost is one or more racks, and these are delivered onto your on-premise location. They're 42U standard racks. They come fully assembled, and we're ready to just roll them in and get them connected. It's installed by AWS. We install the full rack. That's the minimum capacity that we can provide with different configurations of hardware therein. There's a centralized power distribution unit. You can see, actually, if you look in the diagram on the right, in that middle part where there's the blanks right underneath the network switches, that's our DC power distribution system. So we take AC power from your location, single phase or double phase or two phase, and then three phase, and then we can distribute that to the rack through DC power. We have redundant components, so the networking switches are redundant, and we'll talk through how they're configured and how they provide that redundancy and what that looks like. And then the final component to call your attention to, at the very top of this rack, you can see there's a fiber patch panel, and that's our demarcation. That's our handoff point where we connect into your network. We have three main network components with the Outposts. The first is the Amazon VPC Networking, Virtual Private Cloud, and we extend this from the region. So it looks very similar to how networking does when you're operating within one of our regions. We also have local network area connectivity. This is where we hand off the connectivity into the Outpost and connect and integrate into your network. And then we also have regional connectivity. All of our control plane is still originating in the region. That provides that single pane of glass management and the connectivity back into the region. So we'll talk through what those three components look like. Digging into Amazon VPC Networking, if we look at what our region looks like, we have a VPC, a virtual private cloud, and this extends all of the availability zones within a given region. And then within an availability zone, we can create a subnet, and subnets are specific to an availability zone. And those are they have their own CIDR range. That's a subset of the overall VPC CIDR. So this is all just standard AWS VPC networking, the same way it works within the region. What we're doing with Outposts is we're taking this same type of architecture, again, where we have our availability zones, and then we have our subnets within those availability zones. And then we're taking the entire VPC and extending that construct onto an outpost. And the way that we do that is by deploying Outpost subnets. So these are subnets that will live directly within the outpost and not reside within the region. We can see we can deploy instance Y and then instance Z into this architecture here and have subnets that are part of the larger VPC, and then have that overall communication back to the region. We still have the same constructs that we have within the region, being route tables to be able to control destinations for traffic. We have security groups, so we can control what can and cannot access the resources on the outpost and the instances. And we also have network ACLs, access control lists. So the combination of security groups and NACLs provides that defense in depth, the same type of architectures and security levels of control that you'd have in the region, we can extend directly to the outpost and have that same tooling. If we look at what the end-to-end connectivity looks like after we've extended this VPC, if two instances would like to speak directly with each other, that works just like it would within the region. We have the implicit route between those two subnets, and because they're part of the same CIDR, they can route directly to each other. We can also then reach back into instances running within the region. And we'll talk about what service link is, but this rides our service link connection back to the region. We can have our route table on these subnets, and you typically want a separate route table so you can control how the instances in the outpost are routing traffic and accessing other resources. So if we build out what this route table looks like, we have the implicit route here. This is something you can't change. This is just the VPC CIDR. But let's say we wanted to use something inside of the region, or our hundreds of AWS products and services running within the region, or even in this case, an IGW, an internet gateway, if we wanted to have internet traffic traverse out through the region. That's certainly something we can do, in addition to connecting to all of our services running within the region. So in the case of an IGW, here we have a default route and we're pointing it out to the IGW, which means that traffic can traverse back into the region and then egress and provide ingress through that unelastic IP address through the IGW. We can have further routes in this route table as well. So within the region, we might have a transit gateway connected to our VPC. We might also have some VPC peering this VPC into another VPC, and also a virtual private gateway, a VGW, that provides VPN connectivity to other locations. Well, these can all be destinations in our Outpost subnet route table. In the example of using a VPC endpoint, we can connect to gateway endpoints, in this case S3. We can use the prefix list in the region for S3, have that as the destination for our route table, and then have the traffic flow to the VPC endpoint. This also works for interface VPC endpoints. We obviously don't need to do a route in the route table, but we can facilitate those as well and connect back through the region privately to the services that are running there. Another example, we can have some other routes potentially to other VPCs running within the region and have routes that point to the transit gateway. Again, that's running in the region. That component doesn't run on the outpost. We can connect to other VPCs through VPC peering. If the VPC happens to live on the same outpost, we don't actually need to route back through the region. The way that the VPC works with traffic flow, we can route directly between VPCs on the outpost, providing that there's a peering connection there. So we can have that low latency connectivity. We can also peer to subnets and VPCs that live in the region, and that would go back over our service link traffic to the region. If we build this out a little further, we also have, we can have VPN attachments to our VGW, and we can have routes that point to the VGW as a target as well. Probably first and foremost, the predominant use case for Outpost is the low latency, high bandwidth connectivity into the on-prem environment. And this is facilitated through a new type of gateway that we announced with Outpost last year at reInvent, the local gateway, the LGW. And this provides a way to connect into the on-premises environment. And we can have routes in our route table. We just say on-prem here, but this could be whatever CIDRs that we want to route traffic into the on-premises location through the local gateway. There's another concept that we've introduced here as well, and if you're familiar with how an elastic IP address works in the region, where we provide a public IP address that we map to the private IP address of an instance in a one-to-one NAT fashion, we do the same thing with what we call customer-owned IP addresses. So we can see in this architecture, our instance Y has an IP address, and then we can take that and perform a one-to-one NAT to a customer-owned IP, and it works very similar to how an elastic IP address works. It'll actually show up in the console in the same type of place. And once we've performed that mapping, we can then have our instances communicate to the outside network, and the outside network can obviously communicate in as well. We'll advertise that CIDR range out over the local gateway to your network. We can then also connect to anything else running within the region as well. It could be the internet, it could be a direct connection from on-premise. We can route any traffic out the local gateway as long as there's a route in the route table. Another common ask that we've had from customers is they like this whole concept in this way that they can seamlessly have their traffic flow, but then they ask, do we really need this natting? Do we need this customer-owned IP range? And I'm happy to announce that we'll have capability coming where you don't need to use that customer-owned IP range. So instead, in this type of architecture, we're calling it direct VPC routing. You'll have the option to not use NAT. So we can take the individual Outpost subnet CIDRs and advertise them directly out the local gateway. And when we do that, same type of workflow here where we add a route to our local gateway. And then that can just communicate directly out to on-premise workloads and also to anywhere else that you have routes to. So this provides that same functionality we had in the previous diagram. We're just doing it without needing a customer-owned IP range. And this is coming soon. So we're working on getting this out the door, and this is a new capability we'll have. Moving on, integrating the Outpost into your network involves obviously some level of local network connectivity. So we'll dive into what that looks like. So within an Outpost, obviously we have the VPC that we've talked about, which is extended in from the region. And then we have a subnet with an EC2 instance. And then we have our two Outpost networking devices. And these connect into your customer network. The demarcation point is our fiber patch panel at the top of each rack. That's where we'd hand off our connectivity to you. And from there, we can redundantly connect each of our Outpost networking devices into the networking devices on your network. And these could be layer 2 switches. They could be layer 3 switches if you wanted to terminate BGP and do routing on the edge. We leave a lot of flexibility in how we can integrate this into your environment. From a physical connectivity perspective, we support single mode or multi-mode fiber, and that's a LC connector. That's the standard that we use there. In terms of link speed, we do support 1 gigabit a second, but that's more for our dev test racks. If you're looking at a larger rack, more of a production rack with more hardware in it, that's the 10, 40, and 100 gig connectivity that we can support on those racks. In terms of connection numbers, we require at least one connection to each of the Outpost networking devices on our side, and we really recommend that those be redundant on your side of the network. So there's for availability and link aggregation that we have some redundancy there. And even with one link, we can tolerate one of those network switches going out of service for whatever reason, be it an update or a patch. We're able to continue to maintain and run that infrastructure. One of the things that you notice is we have requirements for link aggregation. So regardless, even if we're only doing one link up to the network, we'll still require LACP, and that allows us to provide expansion of bandwidth in the future. So we have plenty of customers that have only done one uplink with the expectation that they'll expand that capacity in the future. So that's why we've kind of gone with that as a standard. Over that link aggregation, we'll run standard VLANs, 802.1q trunking. So we'll have VLANs for service link. Service link is our connection back to the AWS region, and that's where all of the management, the control plane traffic happens. And we do this redundantly across devices. So we have that VLAN, there's two VLANs for service link, one on each Outpost device that would terminate on either your top of rack switch, or they can be trunked to another network switch on the network. And then this would give our connectivity back to the public region. We also have the local gateway that we were talking about earlier has two VLANs as well. And in a similar fashion, we do that for redundancy. So we have a VLAN on each switch, and that connects through to a VLAN on the customer device side. And that provides the connectivity to the local network. Now, if we go a step further here, within that VLAN, we're actually running a subnet. So they can be a /30 or a /31 on each of these devices for the first subnet. So here we're doing a /31, so that's 2 usable IP addresses. We then have an additional service link VLAN subnet as well. Here we're doing another /31. You can do /30. Some equipment doesn't support /31, so we go the route of supporting either. These could use typical RFC 1918 IP addressing, and it's just a point-to-point connection between the switches so they can perform BGP over them. We then repeat the same type of architecture for our local gateway. So our local gateway connectivity, we have a third VLAN, again a /30 or /31 subnet, and then an additional, for redundancy, that's fourth VLAN there for the local gateway. And there we're providing another /31. These can be the same VLAN across switches if you really wanted to, but I've seen most customers go with 4 separate VLANs so they can separate out the traffic and have separate virtual interfaces on the upstream networking devices. Then we have a few subnets that we're running over top of these networks and these layer 2 connections. So we have a /26 subnet, and this can be RFC 1918. It can be public if you'd like. We have some customers that have excess IP space and want to do that. Most don't. We advertise this /26 subnet that you provide to us through BGP to the VLAN on each of our network devices. So we can see here we'd have 2 BGP sessions, one coming from each Outpost network device into your network, advertising that /26 subnet. All of the control plane traffic will originate from that subnet out to the region. We do a VPN tunnel, so all of that traffic is encrypted when it goes back to the region, and that's typically over public IP addresses to the regional endpoints. We then have a local gateway subnet. If you're using the customer-owned IP option, that'll be at least a /26 that you provide. In the future, when we support the direct VPC routing, then we don't need the subnets. We actually advertise the underlying Outpost subnets that you attach to the local gateway. And then we extend another 2 BGP sessions, one from each Outpost networking device to your network, and that provides redundancy for the local gateway BGP sessions to be established. And then instances, once all this is set up and running, our EC2 instances running on the Outpost can communicate out directly over the local gateway, the LGW. The only part that's missing here is the appropriate VPC route table. So we can see here now that we've added in a route table to our instance. It has the implicit route of the VPC CIDR, but then we can add in additional CIDRs that we would like to route through the LGW, the local gateway, and it could just be a default route, a quad 0 if you wanted all of your traffic to go out through on-premise, which is a fairly common ask as well. Some general best practices for LAN connectivity here. When we think about our resiliency method, we're really using LACP for bandwidth aggregation. We're not in any way on the Outpost side using LACP for high availability. Not to say you can't. You can certainly have a multi-chassis lag type of configuration. I've talked to customers that do that. Insert your favorite vendor. They have different standards of ways that they can do multi-chassis link aggregation, but it's not something that we would do on our side. We're using BGP for HA. That's our main method of high availability. So having the redundant BGP sessions across both of our network devices allows us to facilitate any disruptions and make sure that we can keep those connections up and running. So definitely, as you think through your design, LACP, think for bandwidth aggregation, and the BGP is providing the high availability as you design through for your connectivity. Also ensure redundant connectivity. So within each of those LACP connections, if you have at least 2 links, that'll give you some redundancy in your bandwidth capacity. But then also upstream, you really want to have multiple redundant networking equipment at every part that you possibly can. I have worked with some customers who have a lab dev test type of situation, and they've terminated on a single switch, but I still share the same caveat of making sure to consider where things fail, things can fail, and having appropriate redundancy built in, because we've certainly built it in on the Outpost side. Now let's talk about what our connectivity back to the region looks like, our control plane traffic to manage the AWS Outpost rack. This is predominantly done through WAN connectivity. So if we build out our region, we have our VPC with our EC2 instances. And then in our on-premise location, we have an AWS Outposts with EC2 instances and our 2 Outpost networking devices. And these can communicate out to our local network or anywhere else, be it the internet or a default route. We then have our service link traffic, and this is what's providing the control plane connectivity back to the region. Here we're using a private IP range, just a /26, and this needs to go out to AWS. So there's likely some type of edge router in your on-premise location, and then WAN connectivity. And then from that WAN connectivity, you land in a direct connect facility, and you may have a customer cage in that direct connect facility or a colo that happens to have direct connect. And then there's an AWS cage where we actually host our direct connect equipment. And then there's a cross connect between the 2. Now, if you're running some type of third-party provider, you might actually get this the VLANs terminated directly at your on-premise location, at your customer edge location. Just showing for completeness here the full path if you're going through a direct connect facility. But there's plenty of third-party providers that can extend that connectivity all the way to your on-premise location. And then what we're doing over this direct connect is what's called a public virtual interface. So AWS will advertise all of our public IP space towards your equipment. And then from there, you can advertise back a public IP address so we can have the routing over public IPs. That said, we do need to do network address translation or port address translation if you're getting pedantic about the actual definition of what's going on. So you can have one IP address that you do the port address translation of all your service link connections through. And that can happen at your customer edge router, or it could happen at your router at the POP. From there, we connect into the region where we have the Outpost service running. And the Outpost service has public IP addresses. Important to note here, this path can also work over the public internet, and you can have an internet path as a backup path for your direct connect or vice versa. So we're pretty flexible with how that connectivity can get back to the region and work. It just needs to be over public IP addresses. Then, and just assuming we're taking direct connect as a primary path here, we can go all the way back and connect into the region through the direct connect public VIF. From there, our control plane traffic will go out to the service. And then we do have some data plane traffic if you're extending your VPC and communicating with infrastructure that lives within the region within your VPC and subnets that live there. That's the VPC data plane traffic. That also goes through that service link connectivity. So this is what it looks like with WAN connectivity. And again, both public virtual interface as well as commercial internet will work for this connectivity back to the region using public IP addressing. We've heard from a number of customers that for whatever reason, be it that security just doesn't like to use public IP addresses, or you don't use public IP addressing in your network, that we've heard requirements for really not liking the whole public IP connectivity thing. And our answer to that is providing private access. So we constantly listen to what our customers tell us, and since it was an ask, it's something that we've designed for. And this will be coming soon. So another thing that I'm happy to be able to announce today that will be coming. So let's take a look at how this connectivity works. We have our AWS region, again, our VPC with EC2 instances, and then our outposts. And this all looks very similar to our previous architecture here, where we have our service link connection. The difference here when we get into the routing is when we get into Direct Connect. So we're actually going to use a private virtual interface for this connectivity, not a public IP address. This is using all private IP addressing end-to-end. So same type of setup where we have some equipment in a Direct Connect facility that's also cross-connect into the AWS Direct Connect point of presence. Again, this could be a third-party managed offering that extends that connectivity all the way to your on-premise location. Really just depends how you're getting your Direct Connect. And then here's where we're using a private virtual interface. We actually don't require NAT here. We can just advertise this /26 subnet directly to on-premises, because it's just end-to-end connectivity layer 3 without any public IP addressing. Where things kind of get different here is that we have a VPC within the region, and this is something that you would set up in planning for your private connectivity into an outpost. And you'll set a VPC CIDR there that you'll attach the private VIP to. And then you'll provision a subnet within that VPC. And then our outpost service still lives within the region as well, obviously. What's different here, though, is we're actually using VPC IP addresses. So the outpost service is able to actually take ENIs that live within your account and attach to those. So we have private IP addresses that live within the VPC. We'd recommend this be a dedicated VPC just for this connectivity. There's really no other reason to have other services or functionality running over it. This will provide that end-to-end private connectivity. And then from there, the service can reach out and have its control plane traffic. And then our VPC data plane traffic will still work as well and be directed to our VPC within the region that we're extending. So this provides that end-to-end connectivity, but we're using all private IP addressing. So this is a feature we'll have coming soon. Some best practices on regional connectivity. First and foremost, we really are recommending, as a requirement, having a gigabit a second connectivity. And the reason for that is we want the experience of using an outpost to be just as similar in the region as it is to an outpost. We don't want it to be any different. So that's why we're really requiring that 1 gigabit a second connectivity. When you deploy an AMI today or launch an instance, all of that data lives in the region and needs to be pushed down to the outpost. And likewise, when you take a snapshot of an instance today, all of that data needs to go back to the region. And that's all leveraging the regional connectivity through Service Link. And another thing that might not be immediately apparent is that you can completely segregate the Service Link traffic from your local gateway traffic. There's no reason they need to share even a same routing instance. And it's fairly common from customers that have set this up to have a different VRF, virtual routing and forwarding, to segment that traffic and just avoid any mixing up, so you can route those separately throughout your network. And then finally, ensuring redundancy. Outpost is designed to be a connected solution. It's not really meant to work in a disconnected state. Our control plane lives within the region. So things like starting, stopping instances, taking snapshots, all of those APIs will go to the region and then flow down to the outpost. So redundant connectivity is really key. And then I kind of highlighted our SLAs around Direct Connect if you're using Direct Connect for that Service Link connection. And actually, to get 3 nines of availability in terms of uptime goals, that SLA requires 2 links. And if you want to get to 4 nines of availability, that actually requires 4 links going to 2 different regions. So in either case, to meet our SLAs, we need connectivity to multiple regions. So think through that and talk to folks like myself, solutions architects. We're happy to dig in and talk through how to integrate this into your environment. Now that we've gone through kind of all the logistics of how these things work, we'll do a quick demo and see what this looks like end to end. So to start the demo, I've already logged into the AWS Management Console. I'm then going to go to Services, and under My Favorites, I've already launched Outpost a number of times, so it's in My Favorites. I'll go directly to Outposts. And I can see here I have an Outpost ID that's been provisioned and is up and running in Seattle, and it's tied to the Oregon region. I can go in and create a subnet. And this brings me to the VPC console, and you can see this pre-populates the Outpost ID here. I can choose my VPC ID, and then I just need to give it a CIDR here by the /16, so I can just go with the subnet I know that I'm not using, and go ahead and create. And I now have a subnet that's extended onto the Outpost. If I select this subnet, I can actually see that there's an Outpost ID here. So that's how I know that this subnet is an Outpost subnet. If I go back to my Outpost, I can now select the Outpost and launch an instance. And what this will do is it'll give me the option to choose an AMI, so I'll just choose Amazon Linux 2 here. And then it'll list the instance types that are available on this specific Outpost. So I can see the underlying instance types and sizes that I'm available to provision. So let's say here I want to do a C5. And then standard, just choosing how to launch the instance. So it already has the VPC and subnet populated because I chose that already. And I can see that it's an Outpost subnet. And then I can simply launch the instance and choose a key pair, and now I have an instance that's up and running on my Outposts. Now if I go to this instance, I can see it's pending, it's still provisioning, has to download that AMI from the region and then deploy it onto this Outpost. I can see here as well that I have an Outpost ARN too, to indicate that this is being launched on an Outpost. So hopefully that gives a quick overview of kind of the high-level functionality and how easy it is to provision the networking and launch resources onto an Outpost. Okay, so hopefully that was a helpful demo. So I was actually able to get it to turn green and launch successfully, so I call that a success for a demo. So I wanted to end with some resources here. We have our networking requirements. That's the first link I provide there. We have some other really good networking and Outpost sessions that are running throughout reInvent. So I wanted to list those out here. If you're looking for kind of a next step, you want to dive a little deeper into architectures after hearing this session, CMP 310 AWS Outposts, an in-depth guide into hybrid use cases, cloud use cases. That's by Matt Lewis, one of my colleagues. That'll be a great session to tune into and dive more into architectures, as well as we have some storage and some other general Outpost sessions that may be of interest. We also have vendors that have published their guides on how to integrate Outposts. So if you use either Juniper or Cisco, take a look at their guides if you're looking for some help on how to get started and up and running. That brings us to the end of the session. Thank you so much for listening in and attending. Hopefully it was a useful session. You got a lot out of it. I'm James Devine. There's my LinkedIn profile if you want to go in and connect and send me a message. More than happy to have that. And a final PSA, please fill out your session surveys and enjoy the rest of reInvent. Thanks a lot.